everyone. I hope you are all able to hear my voice. Can you all give a thumbs up if you can hear my voice? Yes, thank you. So we will now get started with. So yesterday we spoke about various techniques of operating system. Right? So we spoke about techniques like what is memory management, what is a process, right? What is a port number, right? And then we also saw how to open a port and all these things, right? So today we will continue the discussion on the process management. Just give me a second. Okay, so let us get to the concepts. Okay, so yesterday we have seen about process, right? So we have seen what is the life cycle of a process, right? So usually the process starts, and when it goes to the command interpreter, there is something called command interpreter, which is like a queue for the process. Okay, when it goes to the beginning of that command interpreter, it is called in a ready state. When the previous process is completed, this will start running. So when the process starts running, there could be a case where it waits for something. And if it is going to be waiting forever, then it is blocking the process that is there in the ready state. So now in order to manage this efficiently, what happens is the operating system has some process scheduling concept. So it schedules the process. Okay. So process scheduling is basically assignment of physical processor to the processes to accomplish tasks. The problem of determining when the processor should be assigned to which process is called process scheduling or CPU. So there are so many processes. Okay. Now you can think this of a hospital scenario. Suppose if there are several patients waiting in the in the hospital, okay, to get treatment, and assume that there are only 4 doctors. Okay, the number of doctors are limited. Now I want to call the next patient. Whom should I call? Okay. So basically, we will call people who are more sick. Okay. When if there is somebody who is very sick, we would call them. Or then we will call children if they are there. Then we will call rest. Right. So there is always a priority. Right. So now the same thing applies to the operating system also. Now there are so many processes waiting in the queue. To which one should I assign the priority? So basically, which one should I bring it to the ready state? Okay. Now this depends upon what is the type of scheduling. So there are something called as long time schedulers. Okay. Then short time schedulers, IO schedulers. Okay. So basically, there could be some processes which could be very small, which will just happen in a nanosecond. And there could be certain processes which take quite some time, maybe minutes or hours, right? And there is also something called as IO scheduler. So when should I assign a particular input-output device to a particular process? That is also comes under the process scheduling. Now, so basically what happens is when the scheduling happens, okay, there are several things that might happen. It will switch from running state to wait state. It will switch from running state to ready state. It will switch from waiting state to ready state, or finally terminate. So when the process is a process in execution, okay, a process in execution can move from a running state to a wait state, or from a wait state to a running state, okay, or from a running state to a ready state, or finally once the process is over, it can just terminate. Now, the process scheduling, there are mainly two types or three types of scheduling. One is called non-preemptive scheduling. The other one is called preemptive scheduling. And finally, you have something called as context switching, which is used to suspend the process in preemptive scheduling. So what is happening is, if you take up a preemptive scheduling, okay, sorry, non-preemptive scheduling. So it's a non-preemptive scheduling is a process that has given the CPU, and the CPU cannot be taken away from that process. So yeah, it is like you give that person, okay, you can use it you can use, let's say it is like, let's say your friend is coming to your friend comes and asks you your bike, right? There are two ways in which you can give. Non-preemptive. See, he will give only when he wants, right? It is like if you have seen that that one Vadivel comedy where he takes the cycle, right? Cycle for rent. People in Tamil Nadu might easily understand. He will take a cycle for rent. And then there is a famous dialogue. Right? So it is like that. Non-preemptive scheduling means I gave you, but there is no way I can take back. Okay, so I have to wait till it gets over. Okay, but a preemptive scheduling is a place where it says, okay, I give you for this much amount of time. Afterwards, you have to give back. Okay, so preemptive scheduling is a strategy that allows process that is currently running to temporarily suspend so that the other process is ready get a chance. So this means I will give you process for some time. After that, if there is some other important task, I will give it to that. Okay, that is called preemptive scheduling. Now, context switching is used in preemptive scheduling to move the process from from ready state to run state and to run state. Now, this scheduling basically works on these three things. Okay. Now, this is a very, very important concept that you should know. What are the scheduling algorithms? Okay. First is first come, first serve. First come, first serve means if a process starts first, it will complete first. That is a very standard approach. What is the data structure used to implement first come, first serve? What is the data structure used to implement first come, first serve? What data structure you will use? You would have studied data structure in your school, right, or in your college, computer science. I mean, most of the departments do study data structures and algorithms. So, what is the data structure used for implementing first come, first serve? Yes? Q&A. Q, correct. Okay, Q is the right answer. Okay, Q is the right answer. Q works based on first in, first out, FIFO, right? So first in, first out or FIFO is basically used as a concept for implementing. How many of you have implemented first come, first serve in C language? Has anybody tried? It comes in lab, right? In operating system lab, you will basically study this first come, first serve, right? Then, okay, what is the opposite of first come, first serve? Or first in, first out? What is the opposite? Something called as last in, first out. Something called as last in, first out. Okay, so in last in, first out, what happens? What is the is my voice breaking? Is my voice clear now? Many people complaining about the voice. Is my voice clear now? Okay. Last in, first out. Yes. My voice is breaking. I don't know. Now is it clear?
Now somewhat breaking, sir.
Jano, is it clear?
Breaking, sir, breaking.
Okay. So
Sir, your voice is break. Your voice is breaking. Your internet has some issue, I think. Hello, sir.
Right. Sorry, I think there was a network issue, so I just changed the network. So I did a context switch. Okay, I switched it from one network to another network. That's basically the context switch. Okay, so for scheduling the processes, right? Basically, see, for in your machine, let us assume that you have, let's say you take your mobile phone, right? You have your mobile phone. WhatsApp is running, Telegram is running, Gmail is running. There's so many apps that are running, right? So I'm moving from one app to another app. That is basically called context switching. That means the processor is taken from one process and given to another process. Okay, so they interchange the process. Okay, then for managing the entire processing, there are certain algorithms. Okay, the first one is first come first serve. Okay, suppose if process P1 comes first, P1 completes first. P2 comes next, P2 will go next. That is called first come first serve. Then you have round robin. In round robin means, suppose if I have P1, P2, P3. Yes.
Please share the screen, sir.
Okay, share this. Okay, sorry, I think after I changed it, I didn't change share this. Sorry. Okay, so going back to the now, can you see my screen?
Yes, yes.
Okay, so let us go back to the what happened. So in round robin, what happens is first a process is, let's say there are three processes P1, P2, P3. So P1 will be given for 2 seconds. I'm just making, or 2 seconds, it could be 3 seconds. Sometimes it could be a nanosecond also, okay, depending upon what algorithm you use. So I give 1 second for P1, another second for P2, another second for P3. Then shortest process next. Suppose if one process is running, okay, P1, P2, P3 are in queue. So what it will do is it will find out which process will take the lowest time, and then it will give that. Okay, then shortest remaining time. Shortest remaining time means, now let's say it is a preemptive scheduling. What it will do is, if there are two processes waiting to complete, okay, it will find out which one will complete first and give the priority to that. Okay, then the next one is highest response ratio next. Okay, so there's something called as response ratio. Response ratio means the time it takes to complete, okay, the time it takes to complete divided by how much amount of work is done, basically. So whichever, so basically it means that which process will accomplish lot of tasks, which process will accomplish lot of work. For that, the priority will be given. Okay, so the scheduling, okay, so how is the scheduling criteria done? The scheduling criteria is basically based on CPU utilization, throughput. Okay, how so CPU utilization is how much percentage of CPU is being used. Throughput, processes that complete their execution per unit of time. Okay, the throughput means how many processes are. So if I say throughput is 10, that means 10 per second. That means 10 processes will get completed within 1 second. Okay, 10 per second means 10 processes will get completed by 10. Turnaround time, the time taken to complete a particular process. Waiting time, time taken by a process in ready queue. Suppose you have come to the ready queue and you're waiting, how much time you're waiting. The response time, the time taken for a process to complete is basically the response time. So this is with respect to the process management. Okay. Now let us now look at the file system of the Linux, and then we'll go into some practical aspects. Okay. So just a minute. You can just pause the recording for a minute.
Yes,
So
sir.
now we will talk about something called as the file system in Linux. Okay, file system in Linux is very interesting as compared to other file systems. Okay, now why is it different? Okay, the reason why it is different is, now we all know what is a file. A file is a collection of data items stored on a disk. Disk is nothing but your hard drive, or it could be your pen drive, or it could be an SD card, whatever it is. Okay, a file. What is a file system? File system is a group of files and relevant and information regarding. Okay, file system is a group of files and the information regarding. Now, when it comes to Linux or Unix operating system, there are different types of files. One is an ordinary file. The other one is a directory file. Then you have something called as a special file, right? Then character special files and block special files. Now let us understand what each one of them. Suppose you have a text file. Okay, you're typing. Okay, a very interesting thing. Okay, can you all see my screen? Okay,
Yes.
in Windows, now I'm creating a new folder. Okay, now I say right click new folder and I say folder 1. Okay, now I will ask you to do something. Can you create a folder on maybe on your machines, on your whoever is there on the computer? Try to create a folder called con. Windows, try to create a folder called con. And tell me how many of you created a folder called con. In Windows, try to create a file called con, C-O-N. And tell me how many of you created a file named con. Elumalai says it cannot be created. Anybody else tried? Cannot be created. Yes. You cannot create a file named con in Windows. You cannot create a file name con in Windows. Okay. So you cannot create a file name called Windows, sorry, con. Maybe you can create con_1, con_2, all these things you can create, but you cannot create something called con, right? It is because it is a system specified file. It is a system specified file. Okay, system specified file will not. So that means these are reserved names. Okay, so this is Windows. You can create a file name con in Unix, but I'm just talking about named con window block the name. Yeah, you can create in Linux. What is con? Okay, con is an internal file in Windows. I exactly don't know what is they used for it. It's a secret file. I don't know what it is and nobody knows. But Windows will not allow you to create a folder name called con. Okay, so and Linux is again very interesting. Okay, a file is a file. A folder is also a file. A folder is also a file. A hardware is also a file. For example, your CPU, your all your input devices, right? Like your mouse, right? Your screen, your disk, everything is a file for it. Okay, for it, everything is a file. Okay, for it, Linux, everything is a file. So usually, if you open up the Windows system, you will see these folders: bin, dev, etc., home, lib, temp, user, and some kernel files. This is how it will be. Okay, so bin directory contains the commands and utilities used by user day and day. These are executable binary files. Remember this. Dev. The directory contains special files used to represent physical devices such as printers, terminals. Okay, that means, suppose if you have a computer, okay, your computer has mouse. There will be one file for mouse. There will be one file for printer. There will be one file for what do you call external hard drive. So every physical device is created as a file, and it will be there in the dev folder. Okay, the root is the biggest folder, which is the, you can call the head. Okay, so it is the head directory that you have. Okay, so ECT, okay, etc. is the for system administrator. This directory contains commands and files. Okay? One of these files, MOTD, contains a message of the day, which is displayed whenever we log into the system. So whenever you're logging into the system, Jano, can you just open this MOTD file? Can you share the screen?
Can you stop the screen, sir?
So whenever we log into a Linux machine, it will give us some message. Okay? Whenever we log into the Linux machine, it will give us some message. Right? That message is, can you just type MOTD? MOTD. I think it is not there. Maybe
I need to install.
You don't have to install. It should be there. Can you just go to the dev folder? The ECT folder. It will be there in ECT folder, not this ECT. Okay. Okay. First, do one thing. Put a forward slash and show them the base root structure. Put a forward slash. Okay. This is the root. Okay. This is the root. Okay. So inside the root, you have this folder. See, bin, dev, ECT. Just go to the dev folder. The dev folder is basically all your UILS or LL, yeah. So it has all your, see, you have a file for CPU. You have a file for disk, right? So this machine has a disk. So there is a file. Okay. So you have a mem. There is a file called mem. It is for RAM. So every physical device will be mapped to a, this TTY is nothing but your USB. Okay. Each TTY is a USB port. Okay. Can you now go to the ECT? Do a LS. Does it has MOTD? Okay, I think it is there in the Unix, and Linux doesn't have. That's fine. Okay, so basically this folder structure will have, I think you can stop it. Okay.
Yeah.
So you have a lot of folder structures available in the and each folder has a dedicated purpose. The point that I'm trying to say is each folder has a dedicated purpose. For example, home is a home directory. Lib is basically all your library files. Okay, your library files will be there. Okay, so this is basically this is the entire structure of the Unix directory, which you can go and install. You have installed Linux, right? You can go and look into that. Somebody was asking me, can you explain the process scheduling again? Yeah. So the process scheduling, as I said, right? So if you look at the process lifecycle, see, maybe you have say 4 or 5. You have a C program. You want to run some C program. You want to run some Java program. You want to run some Python program, and you want to run all of them together. Okay. So one program running is a process. Any program in execution is a process. Now, when the program is executing, that program will take that CPU, and during that time, no other people can use that CPU. Now, the program should run so fast that it should allow others also to run. That is the objective. So in order to do that, they have created something called, the operating systems have created something called as a process lifecycle, where they will decide how the process should start, which process should start, which should run, and when it should terminate. Okay, for that, so before the process life cycle, they have something called as command interpreter. Command interpreter is a queue which will have all the processes that are ready to be executed. Okay, the one that is in the first of the queue is basically the ready state process. Okay, so then what it will do, it will basically, it is ready for execution. When it will execute, once the process that is there in the running state exits, or when it gets terminated. Now what can happen, the process that is in running can wait for some other device which is not available, or which is being used by some other system. Okay, then what happens, it enters into a waiting state. Now if it waits for a long time, it is going to block the program that is yet to start the run. Okay, so in order to manage all of them, they have come up with something called as the process scheduling. So in process scheduling, there are two types of processes. One is non-preemptive and preemptive. Non-preemptive is like you give the process and it runs. Okay, till it completes, you have to wait. But in preemptive, what we will try to do is, it will try to set a condition. Okay, if you take more than this much amount of time, I will give the process to somebody else, like that. Okay, and to manage all of them, they have something called as a scheduling algorithm, where based on the algorithm, so every operating system will use different operating system, different algorithms, and one operating system can use multiple algorithms also, depending upon the situation. Sometimes it will go with first in, first out. Sometimes, so depending upon how many processes are there in the queue. Okay, depending upon how many processes are there in the queue, how much amount of CPU is there. Based on that, it will try to run the process one by one. So that is basically the scheduling algorithm. Okay. Right. So let me stop here for the day. Jeno, you can continue with the commands, especially with respect to processes and stuff like that. Okay.
Today I'm going to install app server and DB server in Linux.
Okay, so now you are going to show them how to install the app server and DB server. So you are going to start with app server.
Yes. Can you
Yes. Okay. So
start
Jeno will now show you. Yes, I will stop the screen sharing. Now Jeno will tell you how to install an app server on a Linux operating system. Thank you.
Yeah. Today I have an application server Tomcat and JDK. It is required to run a application server of Tomcat. Okay. First we will install one by one. First we will be going with the JDK installation. In Linux we will be installing a package or a software using their own repository based installation, or it will be a manual installation. Manual installation means the installation binary files we will be downloading and keep it in one folder, and we will be set path to that executable files. Then while running the application, it will be taken from there. It is not in Windows. We'll be installing the exe msi installer. We will be giving next, 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 next. In that, one option will be there, add to path. So in Windows, it will all be in a graphical user interface. In Linux, we will be seeing through the command line. Okay. First, I will move on to the installation of JDK in my Linux. First, I will untar it using tar command. It is none other than zip file, like it is a tar file. It is compressed file, so we will be extracting that file first. Currently, I am now in home folder of demo user. So I have extracted here. This is the folder that we got for JDK. It contains bin and configuration file. Now we will be adding this Java path into environment variables of the Linux for the demo user. Okay. For that, we need to open the bash rc file resides in the home directory of that user. in .bashrc file. Okay, I will open that file with the VA editor. So I will be copying the our installation path of the JDK and paste it here. This 4 line contains the Java path setting in a bashrc environmental variable of the demo user. Here is the Java home variable we declared this path. In path, we are adding the Java home path variable and followed by bin directory. Then while we type Java, it will come into this bin directory and execute the Java file inside the bin directory. For reloading that our setting added in the bashrc, we need to give a command called source bashrc. Then we need to check our Java version using Java version command. I have installed 11.0.15. It is only showing that version. Okay. So application server side, we have installed JDK now. I'm going move on to application server installation. We have a tar file for the Apache Tomcat. I will enter the file. Okay. This is the folder I got. So I will go into that folder. This contains the bin executables and conf directory resides the configuration in an XML format for the which port to be listened, which user need to be accessed, uh, SSL details, all the configuration inside the conf folder. It will be having in a XML format. I am going with the default one, and there will be a log folder. Log folder contains the log. It will while I starting only, it will be writing the logs. No, I have not started. And there will be an web apps directory. That directory contains while you develop a Java code and compile as a war file, and we can deploy inside the Apache Tomcat folder inside web apps. We have to put that war file inside this directory and start the Tomcat server. Okay, I have a sample application war also. I will show that one also. First, we will configure this Catalina path for this Tomcat, same like path setting of Java. I will open the same file. In that, I will put a Catalina path entry. I'm exporting the two variable Catalina home. This is the path, and base also the same path. While starting Tomcat, it will take the Catalina path and base directory while starting the Tomcat. Okay, I'll source the same thing and go to Apache Tomcat. For starting the Tomcat, we need to go to bin directory, and there will be a script to start the Tomcat server. So I will just sh startup.sh. So we have set and configured the environment variable path for Catalina base and home. Temp and all that will be taken by the Catalina path besides. So it is now started. So we can check for the logs. Now it is started. So we are able to see the logs. This is the file that while we starting the Tomcat server, what are the things happening in that server this log file contains. It will take the Java version, Apache versions, command line arguments to be passed, and what are the ports we have configured in that config directory server.xml. Now it is configured for 8080 port HTTP protocol. We need HTTPS, we need to provide SSL settings and all. This is the file that contains the access log of this is the access log. The file which contains while we access the application through browser, it logs all the request things in this file. Just now we started, we not accessed things, so it is empty now. So we will try to access this Tomcat home page from my browser. I have not deployed anything. I have shared putty now. Okay. Stop sharing. I'll share the entire screen option. This is the IP of that machine. In 8080, we are able to access the Tomcat application server homepage. Now we can move on to the deployment of a sample application. I have kept that sample var in home demo user directory. So I will copy that var file into Apache Tomcat web apps directory. Copy source file, destination path is Apache Tomcat web apps. Now we check to that web apps directory. This is a var file we have put inside the web apps directory. It's hosted as a deployable format which Tomcat supports. So while we access that war file through browser, we get the application things. It's a hello world simple page. Okay. Any doubts in this installation of not visible? Yeah, Linux also has GUI, but the servers only contains non-GUI mode only in Linux. We can use desktop as like Windows, we can use Linux, but the thing is, while hosting any application, they will be using non-CLI mode only. Okay. Next, I can move on to Postgres installation. I'm sharing the putty, the same thing. Postgres installation, I will be doing using a apt package manager in Ubuntu machine. It may be vary to the other distribution of Linux. Example CentOS, Red Hat OS and all that will be used yum installing package manager. Here it is apt. Okay. First thing we need to add the Postgres repo URL to the apt source list of the Linux. Through this command, we can add the Postgres repo URL to the apt manager. So it will be adding in the etc apt folder inside source.list.d folder pgdb.list file. It will be adding this content. Okay. Then we need to give a Postgres keys to be added in the trusted GP file. Okay. For that, this is the command. Next, we will be going to install the Postgres now. It will, while I am executing this command, it will install Postgres and Postgres client from the list we have given for the APT. From the latest version, it will be installed. Okay. It will read the file and it will take the what are the dependent package required for that Postgres. All the things it will be automatically done through the URL we have added. Okay. The installation is over. We can check for the Postgres service status using systemctl command. It is saying Postgres is started and it is running active. So we will be check the Postgres version we have installed. See this command. We have installed Postgres 14.6. For the makeup Ubuntu 22, I am using VM, so that version installed. We need to log in to the Postgres client using PSQL command. It will go into PSQL. This is a database. PSQL is a client to connect the Postgres server for querying and doing database operations. Currently, we have not configured any password for the Postgres user. So Postgres user will log in without asking any passwords, right? So we can do a password setting for that Postgres by this query. After logging to the PSQL, you can give Postgres as the same password. We'll say alter role. Then the password is set. We can try that one. Now we will be connecting the same Postgres using Postgres user. We ask our password we have given to Postgres. Okay. Passwords will in Linux passwords won't share in screen. We have to type it correctly. So it is now logged with the password. Now we can check for this Postgres directory structures. Checking the Postgres is running. To take checking via process, we need to use ps command to grab that Postgres. It will show the Postgres process running PIDs and details. Here we can able to see the config file path. This is the config file path it is using. So we can move on to that directory and show the directory which contains our Postgres configuration files. This is a configuration file PostgreSQL.conf which contains the parameters needed for Postgres. It contains the data directory, path, host, HBA path, identity path, PID path, and which port it must be listened, and how much connection it can have. That and all this file contains. Same like HBA contains the access settings of the Postgres. These are all the default entries. So we can have any restriction via IP. This IP need to be accessed, other IP need to be restricted. Here, this is the file they will be putting. And like it will contains the data directory. Data directory only it will be storing the data of that Postgres. That is this one. In this part, we will be having base directory. This file, this folder only, the data will be stored as a files. Okay, that's all about the. We have installed JDK first, then an Apache Tomcat application server, and we have deployed a sample var in it and access through the browser, and we have seen about the database server Postgres installed and configured the password for that and access the Postgres and the data directory and folder structure of Postgres we have seen. That's all about today class. So I'm stopping sharing. Kaushik sir, my side completed sir today.